Let's define f of x to be the power series. That is the summation of c sub n times the quantity x minus a, quantity raised to the n, as n goes from 0 to infinity. If we would expand f of x, we would get c sub 0 times 1 plus c sub 1 times the quantity x minus a plus c sub 2 times the quantity x minus a quantity squared, and so on. Now, remember, f of x does get affected by its derivative f prime. Just like if f of x was position, it would be affected by its velocity, which would be the f prime. So let's go now and actually look at what happens when we take the derivative of f of x. C sub 0 times 1 is a constant and becomes 0. C sub 1 times x minus a, even with the chain rule, simply becomes c sub 1. And as we go down the line, we would get 2 times c sub 2 times the quantity x minus a, plus 3 times c sub 3 times the quantity x minus a quantity squared, and so on. But now what we're going to do is we're going to realize that f prime, like velocity, would be affected by f double prime of x, which would be like acceleration. So if we take the second derivative of f of x, or the derivative of f prime, we would now find that our 0 still becomes a 0, but c sub 1, the constant, now becomes a 0. And now we're starting off actually with the first term of plus 2 c sub 2 plus 3 times 2 times c sub 3 times x minus a plus 4 times 3 times c sub 4 times x minus a quantity squared, and so on. And we can kind of keep going with this. Second derivative can be affected by the third derivative, and we can take its derivatives. And the third derivative can be affected by the fourth derivative, and we can determine those. Now, there is a pattern to be found for the first terms of each of these expanded series. But in order to do so, we need to remove all the remaining terms that follow the first term. How are we going to do that? What we need to do is we need to make those values equal to 0 by substituting x with a, such that all the quantities of x minus a become 0. Here I plug in a. We take a minus a for all the quantities and make them equal to 0. Now, when we remove all the non-essential zeros, this is what f of x and all of its derivatives are left with. So here is what I see. F of a equals c sub 0. F prime of a equals c sub 1. Second derivative equals 2 times c sub 2. Third derivative equals 3 times 2 times c sub 3. The fourth derivative equals 4 times 3 times 2 times c sub 4. Let's repeat this all over again, except this time I'm going to include the 1 being multiplied to the coefficient. So what I'm trying to say is f of a equals 1 times c sub 0. F prime of a equals 1 times c sub 1. The second derivative equals 2 times 1 times c sub 2. The third derivative equals 3 times 2 times 1 times c sub 3. The fourth derivative equals 4 times 3 times 2 times 1 times c sub 4. Are you seeing a pattern? Are you recognizing, hopefully by now, by the fourth derivative, that we're dealing with factorials? Specifically, the nth derivative at a equals n factorial times the coefficient c sub n. Now what I want to do is isolate c sub n, and to do that I will need to divide both sides by n factorial. And I can establish that c sub n will always equal the nth derivative of a divided by n factorial. Let's take that c sub n formula and put it back into the original power series. What that will do is we'll create a Taylor series of the function at a. It will be referred to as t of x, and the summation formula will change, so now it will say the nth derivative of a divided by n factorial times the quantity x minus a, and that quantity will get raised to the n. If we expand out the series, the first term is f of a plus f prime of a times the quantity x minus a plus the second derivative at a divided by 2 times the quantity x minus a, which will then be squared, plus the third derivative at a divided by 6 times the quantity x minus a, which will be raised to the third, and followed by plus fourth derivative of a divided by 24 times the quantity x minus a, which will be raised to the fourth, and so on. In order to reinforce the relationship between the terms, my suggestion is not to use 2, 6, and 24, but 2 factorial, 3 factorial, and 4 factorial. Now, if you hear something called a Maclaurin series, just realize it's a Taylor series in which its center is 0. So replace all the a's with zeros, which makes it much nicer because you're just going to have x raised to the n throughout the different terms. Finally, sometimes we will ask you to approximate with the Taylor series of a certain order. It will be probably represented by t sub n of x, which means it will only go out to the nth degree polynomial. So if I would happen to see t sub 3 of x, what I'm going to do is I'm going to work out the Taylor series until the third degree term, which in this case is the third derivative of a divided by 3 factorial times x minus a quantity raised cubed. If it was a Maclaurin series, then it would just be the third derivative of 0 divided by 3 factorial times x cubed. And that is what Taylor and Maclaurin series are.